Hello, everyone. My name is Arfa Mahabub. I am an automation project engineer from Kohler Company. Just a little bit about what Kohler does is we manufacture a lot of bath climbing products. So one of the first thing that I did when I went to the restroom was what they're using. It's a good thing they're actually using Kohler. So I'm like, good job, Town and Country. Um, so we do have a lot of manufacturing facilities all around the world. In fact, over 50 manufacturing facilities. So this makes us global, right? And we have a lot of challenges uh, that comes with that. For example, in the last 2 years or so, a lot has changed when it comes to working from home, working remotely, and the same thing applied to us, especially when we were actually starting up a new plant in Indonesia, which is halfway across the world. So what happened was we were starting it up, we were having a lot of equipment installation, and pandemic hit. Um, we could not travel. So travel was restricted. A lot of the experts were based in USA or European in Europe because a lot of the vendors that provided those equipment were based in those regions. So they actually would travel to Indonesia to help with the installation and train our technicians, but that was not possible during that time. So we were struggling and we were trying to find out the tool that can help alleviate and mitigate this risk. And this is where we did some investigation and we came across the fact that smart glasses would be one solution to use, and we ended up using smart glass for remote support. And basically, that's what I'll be discussing about today, and also a little bit about our next steps of electronic work instructions, what we've developed and how we want to apply it. So let me start with agenda. One of the first thing, obviously, I want to introduce is the smart glass technology that we used. You know, what hardware did we end up using? What software did we end up using? Then I'll discuss a little bit about the integration steps. It's not just a matter of buying a hardware and putting it out on the production floor. That was not the case. There were a couple of hurdles that we had to face, and we came across and we had to go over it. So it's not just an easy step, right? So I'm going to go through a little bit of that integration step that we took. Then, of course, in application examples, the remote support, followed by the electronic work instruction development. Then everyone wants to understand what are the benefits, right? We're not just applying this sort of technology for the sake of using this sort of technology. It's not just something that's nice to have. Put it on your head and you look like RoboCop. No, it's something nice to have for sure, but there should be benefits to us. Like it should meet certain needs that we're looking for, right? So there's some expectations. So that's what I'm going to highlight is what benefits did we actually capture. Then some of the challenges that we faced throughout this entire process. Then, of course, some of the next steps. What other opportunities are we looking at in the near future? So the technology that we ended up using, the hardware itself for this pilot trial, we used the M400 Vuzix. We tried out a few different smart glasses. We tried out Google, we tried out RealWear, but Vuzix for us at that stage was something attractive just because of the fact that it was light. And we actually tried it out with operators, and operators really liked the fact that it was flexible. So sometimes, you might be right eye dominant or left eye dominant. With the Vuzix, you can switch it around. Whatever eye dominant you are, you can switch it around. It was lightweight. It had touchpad for you to navigate through the apps, and it also had buttons. So in our industry, we manufacture toilets, so hands get dirty. We have a lot of pottery dust. Touchpad sometimes can be finicky in that case. It had those navigation buttons to use as well, so that made it more flexible for operators, and at the same time, voice command, so it was more interactive. Then we use developers such as a TeamViewer in this case. They helped us with both the remote support and electronic work instruction development. Then the application, TeamViewer has this application called the Frontline. It's a website-based software, and also it's an app on the smart glass itself. So we use that Frontline app for this, for our purposes. So the integration steps. I mentioned that we had a brand new plant starting up in Indonesia, which is halfway across the world. That was one of the opportunities that we looked into. And of course, we have to identify which other plants require this sort of technology. We have plants that's being built up in Mexico. We have, some support that needs to be done in Brownwood, Texas. So there's several different plants that might have the need for this technology. Then we looked into what process will benefit this the most. When it comes to electronic work instruction, we look at what tasks takes a long time for training. How can we reduce that training time? How can we make it more interactive for our operators? What's more labor intensive? So we looked at that, and we thought that pressure casting, which is our casting process, one of our very early process in making a toilet, that's very labor intensive, and it had a lot of different procedures. So we thought that this might be a good place to try it out, and it might gain a lot of benefits for us. Then of course we use the remote support feature, and we use the electronic work instructions. But in the feature also, we're looking at pack verification, inspection as well. So opportunities should exist for us to use this sort of technology. Then followed by, one of the first challenges that we faced was, like I said earlier, it's not a matter of just buying the smart glass and using it on the production floor. We actually came across a situation where our IT team had to make sure that this sort of device and software are compatible with our architecture, IT architecture and infrastructure. So we had to go through a lot of assessments. We needed to make sure that it's not prone to hacks. So cybersecurity assessment had to be done. IT assessment had to be done. So we needed to make sure that it's capable of using our mobile device management, like the SOTI mobile control. And at the same time, we needed to make sure that we can install our certificates to connect to our internet, like Wi-Fi, Kohler Wi-Fi in this case. So it had to go through all those hurdles before we could even start using or thinking about using this sort of technology. Then legal as well. What do I mean by legal is there's a couple things. First of all, this sort of technology has a camera, so we can actually gather videos, pictures on the production floor itself. So we might be actually capturing confidential information. This is where the cybersecurity comes in as well. It had to pass all those penetration tests. Then at the same time, different parts of the country, different parts of the world, they have different laws. Union plant versus non-union plant. We don't want to step on anyone's toes. We don't want to be able to capture pictures and videos without consent, right? So that's why we needed to get in alignment with our legal team as well to make sure this sort of technology is complying with all the regulations. Then the next step would be to actually buy the device. So we ended up buying the smart glass, and we ended up buying all the accessories like the frame, the lensless frame that we bought. You could wear it with the frames or on a safety glass or headband, however you see fit in your place. So we ended up buying that. Then we ended up buying actually 2 different licenses. For each of the smart glass. One license, which is a front-end license, meaning the license that you would need on the smart glass itself. Then the other one would be a back-end license. In this case, if I'm remotely supporting someone, I need to go onto the Frontline website and I need to log in. So I need license for that. So for remote support, we ended up using 2 licenses, which is required. But if it's just electronic work instructions, then 1 license for that one smart glass would be enough. Then, of course, we had to go through training. For example, me being the project manager, I was trained by TeamViewer on how to use the smart glass, and at the same time, how to develop electronic work instructions on the website software. Then, once I'm trained, I can help train and relay all this information to my production supervisors or to the operators as well. So that's the integration steps. Then I want to share a little bit about one of our first application, which is the remote support. Remote support is a widely used application when it comes to smart glass. So this was like the perfect tool during the pandemic time to use. So what we did was we shipped out one smart glass all the way to Indonesia. And since this is a brand new plant, and one of our technicians, Dwiki, is our quality assurance technicians. He needed to learn on how to use torque tools. So we use torque tools to torque down the valves in our tanks, the toilet tanks. So it was a brand new process for him. He needed to understand how to set up these tools, how to actually operate these tools, what this button does and what that does. He needed to understand that. So what we did was we sent it out. We're going to train him using this. And obviously there were other things that you could use. We use Teams, we use video chats, but we need something more interactive. And at the same time, I'm remotely supporting him. And on the very top, will be your top left. So on the very top left, you would see his point of view, that I could exactly see what he's doing. So it helps me to guide him better on how to train to use this tool. And the other thing is, Dwiki, he speaks really good English, but when we're talking over the phone, there's definitely a little bit of language barrier, right? So through videos, through annotations, through pictures, that's how I can relay my message to him. At the same time, he's understanding me right away, especially when I'm using annotations, like I'm drawing up boxes with arrows, like this is where you have to go navigate in the controller to set up this torque values. This is where you have to press in order to, let's say, go from a clockwise to anti-clockwise movement of the torque tool. So me annotating all this in a live stream, and he's seeing it on the smart glass display itself, it makes it more faster and easier for him to understand how this tool actually works. And that's exactly what happened. And at the same time, I wanted to share with Dwiki on some of the places that we actually have this sort of tools, how it's actually set up on a production line in a seasoned plant. So I was sharing my screen, and he can see that on the smart glass display that he has right in front of him. And he's seeing that this is how it's set up, and I'm going through the process with him. These are the tool setups. You have racks here, you have a conveyor here. So this is how it will look like once you actually have it, installed on the production floor. And at the same time, I wanted to share with him a little bit more about, what other equipment you might need. You might need a tool balancer. So what I did was I just went to Google. I showed him some examples of what tool balancers that we might need to buy, some prices of it. So I'm sharing all this information, and he's seeing it. So he's gathering all this information from me, like on the spot. And the best thing about this was, when he's getting trained, and this was his feedback to me, was both of his hands were free, right? So he's learning, he's listening to me, he's seeing what I'm trying to annotate, and he could use both of his hands to use the torque tool, set up one and use the other one to actually drive the torque tool. So it was very easy for him during the training process. And that's, you have a better advantage over the phone, because I also asked him, how did you like using cell phones or video calls when we actually did, let's say, for example, Teams calls? He said that the fact that he was able to use both of his hands, it was so that's one of the good positive feedback that we got. And I'm going to show you a video just to give you a good like a brief idea of how this annotation really worked. So in this, I wanted to show him, it might seem very straightforward that this is a button that you need to click, but this was his first time using the tool, so he needed to understand what's going on. So I told him, flip the tool, I'm going to snapshot. So I took a snapshot, and he's seeing this live stream, and I am seeing his screen as well on what he's doing, and I'm annotating to him, this is what you're going to have to press if you want to move from clockwise to anti-clockwise, and he got that right away. So that's just an example of how I'm capturing what he's saying, and how I'm interacting with him to let him know, stop for a while, I'm going to start annotating. So our next application, and this is still a work in progress, we want to develop electronic work instructions in the sense of converting from a paper job-based work instructions and make it more interactive. So first of all, we need to identify the process. The process was pressure casting, which is labor intensive because there's just so many different steps, so many different standard operating procedures. So we picked one that made the most sense. On the left-hand side, that's pretty much how our our standard operating procedure looks like. Our current one, the paper-based ones, and you could see tasks with different steps, and there are pictures related to some of these steps. So we wanted to take this information and convert it into an electronic work instruction. We wanted to make it more intuitive and interactive for our operators. So what we did was we gathered pictures of the tools, we gathered videos as well, and we just made it more interactive. And those are actual displays of what the operator would see on the smart glass. So I'm going to show you two videos, and these two videos are going to show you the exact display of how it looks like. So the first one is just showing you the navigation of different pages. It will show you that, okay, this is the step you need to follow. For this step, you need to use this equipment, and you will just voice command video, and it's going to pop up that video. It's going to show you how that step is being completed, or how it should be done by an experienced or a seasoned employee. You know, in paper job-based instructions, you can describe the tool all you want, but with a picture, you know, you're speaking thousands of words with just one picture. It's easier or more interactive that way. And that's one of the things that we are foreseeing, that it will help with someone we hire new to get trained. So the reduction of training time will be, you know, significant. This next video just shows you a different narration. So it's a little faint, I believe, the sound. So the idea was it's the same job, same tasks. One is being narrated in English, and the other one will be narrated in Spanish. So we are basically trying to develop a dual language electronic work instruction of the same process. And this will help with, you know, we have operators, we have a very diverse pool of operators, and we have, you know, plants in Spanish-speaking countries as well. So this will help with, you know, the preference of an operator learning in Spanish versus in English. So we have the capability as well built in it. All right, so the benefits. One of the first benefits that we realized was, and this was actually done in another division, it was in a faucet assembly, because we do make faucets as well. 50 to 60% faster assembling a faucet when using a, you know, electronic work instruction versus a job-based work instruction. So that's one of the things that we've realized. The other one is, with the electronic work instruction example that I just shared, we are foreseeing a 30% reduction in training time. And with remote support, this is a given. When we're supporting someone, especially during a pandemic, someone across the world in Indonesia, we don't have to be there physically. It's an interactive training. So we are saving a lot of money when it comes to travel expenses. And at the same time, if I'm an expert in a process, and we do have expert in our process, right? And in Indonesia, if someone needs help, we could just, you know, sign on and log into the for the remote support, versus me, you know, booking my arrangements, and I'll only be there physically a week from now. So it's just a really quick response when it comes to the support. So one of the things that we want to do in the near future after all this is we want to be able to do packware verification inspection as well. So we are foreseeing some improvements in quality control. The other one, like I mentioned earlier, like Dookie, we had positive feedback from the operator. They liked the fact that it was light in weight, at least the smart glass that we were using, and the fact that it's hands-free. Some of the challenges that we faced, and First of all, just getting the buy-in from stakeholders. It was a little challenging, to be honest, because everyone has a different mindset on what to expect from this technology, and it's just not a thing like you just want to have it for for the fun of having it because it looks cool. No, we needed to get buy-ins from management all the way to our one of our most important stakeholder will be operators. They are the end user after all. If they don't like it, then we're not going to sit in this project, right? Because they need to be comfortable using this. So getting alignment from all the stakeholders was important. And like I mentioned earlier as well, we need to go through all the IT cybersecurity assessment and get alignment from legal as well. So it took time. It wasn't just a matter of buying it and we could start using it. It took months to get all this approval and assessment done. So you just have to be wary of that, that it will take some process in order to get alignment. The other thing was Wi-Fi connectivity. This was very important, especially in a new plant. Uh, when you saw Dewey getting trained, he was actually getting trained in an office instead of a production floor because we did not have Wi-Fi coverage during that time on the production floor. Even in the office, it was an on and off. You need a good Wi-Fi coverage for remote support. There were actually a lot of times that I also got frustrated myself because we lost that connection. It just kept going on and off. So having a good coverage is very important. And one other thing was, like I mentioned earlier, the comfort level of the operators. Like I said, they are the end users. They have to be comfortable using it, and they have to also see the benefits. And if we're making their job harder by using this sort of technology, then it's not going to work. We needed to make it more interactive, more easier for them to use. So that's one other challenge that we needed to overcome, just getting their buy-in as well. One other thing that I did not add in here was, but I should have, is the safety aspect. We need to get it in alignment with our EHS, our safety group, to make sure that when they're wearing the smart glass, it's not exactly in their line of sight. And that might be very dangerous, especially when there's forklifts going around the production floor. So the thing with the smart glass that we use, you could move it out of the line of sight and you're just looking up this way to look at the display. So that kind of became more comfortable with our safety personnel. So they gave us the okay to use it. Some of our next steps. So let's see here. First of all, the electronic work instructions that we developed so far, we want to actually start using it on the production floor, and we want to start using it on a Spanish speaking plant because we want to test out that dual language and see how interactive that really is. Then once that has been verified, because we need to actually take small steps, we need to gain people confidence. Our management, they need to see the benefits as well. So we need to do some small steps. And once that's been verified, then we want to start looking into actually having checklists completed. So let's say each process has different stations, and we want to make sure that there's a checklist and the operators is completing their task accordingly. And the good thing about this sort of technology is there's timestamp to it. So there's traceability and visibility that we could actually see, okay, the operator completed all these tasks and it took about 5 minutes or so. So from there onwards with that traceability, we can learn how to improve that process, going forward. The other one we want to check out in the future is the packing verification and the inspection. So before we ship out a box of toilet to a customer, we want to make sure all the hardware is inside that box. So some way of packing verification is important to us. And at the same time, take a picture right before you close the flaps of the carton. So when it does come back from the customer, we get a quality claim from the customer, we can trace back and see what exactly went wrong. So we want to be able to use this technology for those sort of application. Then the other thing is we want to actually use 3D augmented or exploded view of diagrams, some 3D rendering as well, to make it more easier for our maintenance staff to, let's say, troubleshoot a machine or for training purposes as well. And this is where we need collaboration from, let's say, developers like TeamViewer, vendor, like actual equipment manufacturer, and ourselves. So these are some of the next steps that we've identified after actually analyzing, with the feasibility and impact diagram to see what will have the most impact to the business and how easy or how hard would it be to actually implement this on a production floor. So with that, I conclude my presentation. And if you have any questions, I think we have a few minutes, so just feel free to ask. Otherwise, I'll be out there. Okay.
We do have a question from the app, but if anyone in person wants to ask one, let's start there. I'll go and I'll ask the question in the app.
Sure.
And I think it's someone who might even be here. What is the name of the smart glasses you used? Thanks. If you're not afraid to divulge.
The smart glass that we...
Oh, it already was answered.
Yeah, so we use the Vuzix M400
Sure.
for this particular application, but we've tried out other smart glasses as well.
Sure. Any other questions? Oh.
Hey, my name is Weston Dudley. I work with Northrop Grumman, using AR for work instructions for making aircraft. How did you come to use that type of glasses? Why didn't you use HoloLens or any of the other types of technologies?
Okay, yeah, that's a very good question. And why did we end up using the Vuzix M400 versus other smart glasses? For this pilot trial, we got direct feedback from operators. They liked the fact that it was light. And we also like the fact that, like, if you're, I think some glasses, this isn't exactly augmented reality glasses. This is more just a smart glass with a display in it, right? It had the flexibility of switching, which side you want to place the glass on, depending on, which eye you're more dominant on. So that was one factor. The factor was it was light, so it was flexible. You can move it around however comfortable you are. And the fact that it had both touchpads and buttons. So we thought that this might be a good, a startup trial sort of a smart glass to use. Because to do a trial, we need to start off with something that will be welcomed by the operator themselves, right? And then from there onwards, we could actually start understanding the benefits that we could actually roll it out and actually show it to our management. So that basically lightweight, flexibility of moving it around, and having both touchpad and buttons. That was the main reason.
We got another one right here.
Hi, my name is Greg Cooper. I'm with Honda. I'm an innovation engineer. I have to agree with you on the recorded video for training and how that is much more impactful than the printed side of it. My question is who creates that content? How do you delegate the responsibility for a particular work area to capture those steps, save it, and then integrate it into the software mix?
Yeah, that's a great question. How do we actually ended up gathering all this data, and who's responsible for gathering all this data, right? So for this trial, it was a collaboration. So we needed to understand how we can actually develop and create a work instructions, right? So this was something new, at least in my department, it was something new, right? So we needed to collaborate with TeamViewer to come up with the development. But at the same time, we already had a standard operating procedure to work off with. And the actual videos was captured by, Kohler employees. So there were a couple of things that we did. We took some point of view sort of video. So we actually used a smart glass to capture the videos, and we put it into the electronic work instructions so you could actually see how an operator does it when it comes to, point of view. So data gathering is mostly on our side. So the people who's going to end up using it, we're the one who has to capture the data. And after all, we are the right person to capture the data because we know exactly what we want to train and what we want to show to, let's say, a new employee. So we ended up capturing the data. We developed it with TeamViewer in this case. But in the future, going forward, once the first electronic work instruction is done, that the whole responsibility of doing this will become will be borne on Kohler. So someone from Kohler has to be trained on how to develop this sort of work instructions. Okay. All right, thank you.